All right. What do we got? Andrew, can I have a blank? I don't remember what I said. Okay, so this is from an article that we're going to read for next week by Paul David and Bill Sundstrom about determinants of fertility. So on Tuesday, we'll look at population and fertility. And this is one of the results, the regression results from that article. So let's see what we got. So we answered the first one, that the thing in parentheses is the standard error. And how did you know it was a standard error? It says, exactly, because at the very bottom it says, note, standard error is in parentheses. So every time you get a regression result, you just have to look around and figure out what it is. And hopefully the author tells you. How do you know which coefficients are statistically significant in this table? The ones with the stars. And they tell you also in the note that 1 star is better than 2 stars. So 1 star means you are, oh no, the other way around. You know what, that's because that's a typo on my part. 1 star is you're 95% confident, and 2 stars is you're 99% confident. That's my mistake, so I switched those two rows. Sorry, my bad. Oops. Okay, number 3, let me get down the front. You guys can sit down. So does the availability of rural land, so that's one of the independent variables that's measured, that's on the side of the table, does the availability of rural land affect the child-woman ratio? Child-woman ratio is the dependent variable, it says that at the top. So does it affect it, yes or no? And how do you know? The answer is no, and how did you know the answer was no? Because there's no star. So you looked at the row that said log rural land availability index, and for all states, it said 0.0269, and there was no star. You could have done the math. You could have calculated the t-stat in your head by taking that coefficient, 0.0269, and dividing it by the standard error, which is 0.0484. Just round. 0.03 over 0.05. 3 over 5. Oops, that's not bigger than 2. So even without the stars, you could have figured it out by doing a real rough calculation in your head to see whether or not those ratios are larger or smaller than 2, as somebody pointed out in absolute value. So rural land index doesn't matter. We know this because there's no star on it, or we could have done the math. If one state has more rural land available than another state, does that mean the more rural state would have a higher, lower, or the same child-woman ratio? And I should have said in here all else constant, so presume all else constant. So if one state has a higher rural land availability index, what does that tell us about how that state compares with a state with less rural land available? Tells us nothing. That's right. So the fact that the coefficient is not statistically significant means that we can't draw any conclusion, or there is no systematic effect of the availability of land, rural land, on fertility, on the child-woman ratio. Is your answer to 3A necessarily true for each and every pair of states? No. Because what you have is these econometric results are giving you on average. So the econometric results are on average for the data set as a whole. What's the relationship between, say, rural land availability and the child-woman ratio? It doesn't mean that each and every pair within your data set is going to behave the same as the average. So it's always true in everything we do in economics. We're looking at the average, and any particular person, any particular, in this case, pair of states, may not behave in the same way as, on average, the rest of the data set does. So we can't draw any conclusion about any particular pair, but we can make on average statements. All right, number 4. Does the mix of non-farm and farm labor in a state? Ooh. Which row is that? I changed the words, didn't I? So when you look at the table, there was no non-farm and farm labor row. But there is a row that says the ratio of the non-agricultural to the agricultural labor force. So the mix of non-farm and farm labor, that's the same as the non-ag to ag labor force row. Sometimes the words get changed, so you got to make sure you're not looking for exact matches and are thinking about what do these various words mean. Okay, does the mix of farm and non-farm labor in a state, does that matter, yes or no? How do you know? Stars, exactly. And is the relationship positive, negative? Negative. So it's a negative coefficient, and it's negative for the whole data set for the northern states and the southern states. And that coefficient has stars on it in all 3 of those cases. So it's statistically significant and it's negative, which means we can reasonably conclude that the mix of non-farm versus farm labor had an effect on women's fertility in 1840. Does that mean that that relationship holds for each and every pair of states? No. Because econometrics, the type of analysis that we do as economists, tells us about what's true on average, but not necessarily for each and every particular, in this case, pair of states. You'll do another exercise like this in section next week, right? You'll do another exercise with a different data set in section next week, and then, of course, all the way along we'll be reading econometric results in our tables. Do y'all have any questions before we go on? Yeah, wait a minute. What's your name? Nick. 4A? So 4A said if one state has more non-farm jobs than another state, will that state have more? Will the state with more non-farm jobs have a higher, lower, or the same child-woman ratio? Ignoring the typo of the stuttering A at the end of the sentence. So the row that we're looking at is I didn't count the rows. It's a row that says ratio of non-agricultural to agricultural labor force, and that coefficient is negative. So that tells me the higher the non-ag to ag labor force, the lower fertility will be. Yep. Yes, and I forget your name. Allie. It's okay. Yes. So more stars is always better than fewer stars. So the typo I made was that the 1 star should be significantly different from 0 at 5%, and the 2 stars should be significantly different from 0 at 1%. And I was talking when I was doing the presentation about 95% confident. 100 minus 5 is 95. 100 minus 1 is 99. All right. Cool. Other questions? Here. Goodbye. I have much more to do. I'll do it with you. There we go. Okay. Any other questions on the metrics? You get lots of practice over the semester. All right, transportation. So transportation, talking about transportation, we were looking at land on Tuesday. We looked at Indian removal, which then allows for even more movement of the white population into the various parts of what are now the United States. The share of the population that's living in the West is increasing rapidly over the antebellum period. Ante means before, bellum means war, so this is all pre-Civil War. So during the pre-Civil War or the antebellum period, the share of the U.S. that's living in the West is increasing quite markedly from 15% in 1810 to 41% in 1860. And the question, of course, is how did all these people get there? How did the people get to the West? There were no interstate highways. There was no transcontinental railroad. There was a bunch of land out there. And so the question is, how did the people get there? So here's my little travel log for the day. That's a picture I took. That's at the Arch in St. Louis. And underneath the arch, which is huge, that arch is huge. And there's like I won't do it because it just defies gravity. But there's a thing that goes up, and you can go up into the top of that arch, which is like 50 stories off the ground. And you can be up there. Terra firma, very important. Terra firma, very important. I don't understand the engineering of it. I don't want to be that high. You can go that high. If you don't want to go up that high, that's fine. Down on the ground underneath the arch is a fabulous museum. It's the Museum of the Westward Expansion. And basically everything we're going to talk about today is covered in that museum. So you can stay here, or you can catch a flight to St. Louis and go to the museum and catch it all there and then come back tonight. All right. So this is the map I referred to on Tuesday that's in your book. The U.S. landmass is essentially complete by the mid-1800s. We've got the Louisiana Purchase here in 1803, the annexation of Texas in 1845, the Mexican acquisition, which includes us, in 1848, Oregon Country, 1846, Gadsden Purchase, Florida acquisition. And so by the mid-1800s, the landmass of what is now the United States is essentially complete. The movement of the frontier west goes relatively slowly. So even though the landmass is complete, the frontier, which is like how far out have the white settlers gotten. So here, let me do my little pen. Ooh, what did I do with my pen? There it is. So this line is 1800. So by 1800, folks have settled into western Kentucky, but not much further. Let me jump ahead to 1840. By 1840, here's the frontier is out here just beyond the Mississippi River. By 1860, the frontier is here into the Plain States. Here we go. Oklahoma, Kansas, Nebraska, and the Dakotas. So that's a long time, right? This is 1800 to 1860, 60 years, and we're still just moving basically past the Mississippi River. Okay, how long did it take to get there? In 1800, this first map is 1800. In 1800, to get from New York, which is here, to Chicago, which is there, took 6 weeks. So in a week, you could get only as far as this line here. So in a week, you could get from New York City to Lake Ontario, so western New York. You could get 2/3 of the way through Pennsylvania. You could get down to North Carolina, to about halfway down the coast of North Carolina, but that would take a week. So travel times were very long in 1800. If you were going to go from the East Coast out here to near the Ohio River, you're talking weeks and weeks of travel. There are travel improvements that are pretty marked over this 1800 to 1857 period, so that by 1857, to get from New York to Chicago is taking you 1-2 days that you can get there. So it went from 6 weeks to less than 2 days in 60 years. That's phenomenal. That's an enormous improvement in transportation. That improvement in transportation is captured in what variable in our growth equation? That improvement in transportation is captured in A. That's right. So this is an example of an improvement in total factor productivity, which leads to rising living standards. It leads to rising living standards for a lot of reasons. One reason it will see is specialization in trade, but that's not the only reason. All right, so let's look at these development in transportation networks. So where's my watch? There it is. So I'm going to run quickly through this since we spent time on the other. The initial transportation networks, we had overland routes that were roads, we had river routes, and we had ocean routes. So initially we're taking advantage basically of the routes that had been there in the pre-Columbus era. So in the era before European settlement, there had been river routes, there had been the ocean, and there had been overland routes. And so initially, the white settlers are taking advantage of similar transportation. The overland routes are shown in this map, which is also in your textbook. I showed you the other day the National Road, which goes now from St. Louis to Washington, the Mormon Trail and the Oregon Trail, which start out from Missouri and Mississippi River and bring you to either Utah or on into Oregon or over the Sierras into California. But there are a handful, right? That's not a lot. There's a handful of major roads that people can use to move from east to west. These are long journeys that are taking place by covered wagon, sometimes in large groups, sometimes in single families. So it's a long and arduous journey. One of the developments during the early era, so early 1800s, let's say, are turnpikes. Turnpikes, what's a turnpike? You know, today they talk about the turnpike if you're back east. Let's say take the turnpike to such and such a place. A turnpike, do I have a space here to draw a picture? Yes. So this is a view from space. So looking down, a turnpike basically looks like this. And a turnpike is something that turns. And we used to have them in order to go into stores. They don't have them anymore. Where do they have turnpikes now? Disneyland. Everything in this class gets back to Disneyland, right? There are still some things like this in Disneyland when you go into certain rides. You know, when you go into a ride, and, which ride? Not the Pirates. Well, yes, that one too. But the one I want is with the ride with the big roll, like ball. Indiana Jones. When you go into Indiana Jones, you have to go through the turnpike. That one's on its side. So you go through it, turnpike. So turnstile on its side for people. Turnpikes were really big, and turnpikes were a way of collecting tolls for roads. So now you go through the toll station at the bridge, and before people would go through this turnpike. So this thing, it looks pretty small there. That's huge. It's big enough so that a covered wagon fits in here and goes through the turnpike. And the turnpike is a way of collecting tolls. These turnpike roads initially were plank roads. That is, they were wood. We talked about this the other day. If you're going to have wood and you're putting wood down on top of dirt and in an area where it rains and snows, how long is that wood going to last? Maybe a year. So you're going to have very, very high depreciation rates. If you have very high depreciation rates, if your capital has a very short life length, what does that do to your living standards? High depreciation rates make your living standards go down. So having the plank roads is better than just having the dirt because the wheels of the wagon don't get sucked into the dirt and the mud. Oh, particularly the mud. Oh my gosh. So I grew up in California and then I went to UMass and taught at UMass, which is in western Massachusetts. And we lived out in the country outside of Amherst. And they have mud season back east. Who knew? I lived in California. We have fire season, which they don't understand. They have mud season. Mud season is around April or May. And mud season is when the ground, which had absorbed a lot of water from the melting snow but had been frozen, when the ground starts to thaw. And all of that moisture that went down into the ground during the winter thaws. And if you take dirt and water and you mix it together, you get mud. So one day, I came home from work and I parked my car at the end of our driveway, which of course was not paved, because when you live out in the country in western Massachusetts, you don't have a paved driveway. Got out of the car, stepped out of the car, took 2 steps, and left my shoes behind me. Walked right out of my shoes, because the mud sucked the shoes off of my feet. So if the mud can suck the shoes off of your feet, imagine what it can do to the wheels of a covered wagon. So that these roads, without having something on top of the road, it's going to be pretty hard for these roads to be passable in all kinds of weather. So planks are one way of trying to have passable roads, and then they charge tolls. You have to go through the turnpike to pay the toll, and thus they're called turnpikes, and they still exist today. So you go to Massachusetts and you ask people, how do you get from Springfield, Massachusetts to Boston? They'll say, take the pike. Except they'll say it with a Boston accent, which I can't do. Right? Take the pike. Take a claw on the pike. And great thing on Facebook yesterday. Khakis? Yeah, okay. So what are khakis in Boston? They're khakis. All right. Some of these roads are, initially they're built with private funding. Where do you think the roads are going? The privately funded roads. What's the destination of that road? Think Thursday nights or Friday nights, but I think it's Thursday nights. Think Friday nights, bars. So the initial destination of these roads are the pubs. The pubs pay to have the roads put down because it brings the customers to the pubs. Is that Thursday or Friday night activity? Both. Yeah, see? You're thinking she can't possibly know that, can she? Yes. Been around a while. Initially private funding, but the private funding is going to take people to a particular destination like Henry's and not other places. Eventually we get public funding of these roads, which is a reflection of the recognition of economic concept, positive externalities. So the existence of the road provides benefits for more than just the people who are on the road. It's increasing trade. It's allowing easier access for everyone. And so initially private and eventually public funding of these roads. All right, you got your map? Now we're going to do water. To do water, we have to talk about rivers. Mississippi, M-I-S-S-I-S-S-I-P-P-I. Learned that when you jumped rope. If you did not jump rope, you never learned how to spell Mississippi. Mississippi. One thing to keep in mind is when you see a ragged border between two states, it's likely that's a river. When you see a straight line, it's probably not a river. Because rivers tend not to go on straight lines. Rivers tend to go ragged, 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 ragged. Okay, so the Mississippi, which is the biggest and mightiest river of all, starts up here in Minnesota and comes down and forms this border between states and then jogs out this way. So that's the Mississippi. M-I-S-S-I-S-S-I-P-P-I. Mississippi River. That's the big one. That's the most important. The Missouri River starts in, oh, gotcha, good. All right, starts in Missouri, and in fact starts in St. Louis, Missouri, and goes across the state, and then here's another jaggedy border, jaggedy, 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 and then goes off this way. So that's the Missouri River. So it goes west across Missouri from St. Louis to Kansas City, and then follows that border. The Ohio River probably is going to go somewhere near Ohio. So see this jaggedy border here? Jaggedy, 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 Jew. There we go. The Ohio River forms the northern border of Kentucky and the southern border of Ohio. And the Hudson River. The Hudson River, if you've been to New York City, you've seen the Hudson River. The Hudson River comes down here parallel to, but not exactly on the border between New York and the states to its east, and then comes out right there at New York City. So when you're in Manhattan, on one side of you is the, this way, east. On one side of you is the East River, and on the other side is the Hudson. All right. We'll come back to our map in a minute. Boats. Initially, the boats that we had initially were flatboats. Oh my gosh, we're back to Disneyland. Okay, now we're going to go to Tom Sawyer's Island. There's two ways. Maybe there's only one way to get to Tom Sawyer. Tom Sawyer's Island is no longer Tom Sawyer's Island. They've changed it. They changed the name of it, but it's still Tom Sawyer's Island to those of us who remember and care. So Tom Sawyer's Island, to get to Tom Sawyer's Island, you take the raft. The raft is basically a flatboat. Let me see if I can make the link work. And there we go. Cool. So there's a flatboat. I decided to show you the whole site because I can show you what's at the bottom of the site. So there's a picture of a flatboat. Oops. Why did it do that? Don't do that. I can't use my flasher. So it's flat along the bottom. I can't use my pen here because it's not a pen right now. So it's flat along the bottom. It's just sitting there on the water. I mean, on the land. So that's a flatboat. This is a recreation. There's another image of the flatboat. The reproduction of an 1830s flatboat. There's the inside. There it is again. And this is why I had to include it because down there at the bottom, you see what it says? Go Bears. So I had to show you the whole site, but it said Go Bears at the bottom. Okay. So flatboats have a flat bottom. They're pretty easy to make. Doesn't take a whole lot of genius to make a flatboat. You can make a flatboat that has a place where people can get some relief from the elements, so they can sleep there or just get out of the rain or the sun or whatever. Or you can make a flatboat like the ones they had in Disneyland, which were just flat, right? Which didn't have any little houses on them other than to contain the motor. At this time, they didn't have the motors that the flatboats in Disneyland have, right? So they used poles. You knew that, right? That they used poles to get these things down the river. So they would float with the stream, or if they needed to go a little bit faster, they would put the pole in and pull their way down the river. A keelboat is not flat on the bottom. It's more triangular on the bottom. Where's my picture? There's a picture of a keelboat. So you can see that the keelboat, that's going to take a little more engineering and is much more expensive to make. The advantage to the keelboat is you can steer it. So you've got a keel. You've got a steerer. You've got a keel in this thing, and you can steer the keelboat as it goes down the river. The flatboat, you're going with the current, and you've got those poles, and you're using the poles to kind of push the flatboat around to try to avoid the snags, which are the trees that have fallen over or grown up through the river and are sticking out of the water, which can catch the bottom of your boat and pretty much destroy your boat. So the advantage to the keelboat is you can navigate around these various things like the snags. The disadvantage is it takes more time and money to build a keelboat. The third kind of boat is the steamboat. The steamboat comes along later. Oh, I'm running through notes too fast. Particularly the 1830s on is the life of the steamboat. You can see a steamboat in the background in this picture, or here's another picture. Steamboats go to New Orleans, which we all, of course, would like to do for Sunday's game, but we can't. Go to New Orleans. And you can go for rides on a steamboat that looks like this, which is a replica of an 1800s steamboat. They also have one at Disneyland. So the power for this comes from the steam, which is made from burning wood or coal. Burning wood or coal creates heat, creates steam. Steam makes things move. I'm not an engineer. I don't understand these things. I still think electricity is a little bit magical. But steam makes things move, and it makes things move, and that makes other things move, and that makes other things move, and then the paddle gets to go, and then the paddle gets the water going with it, and the paddle's going around the back, and whoop, there goes your steamboat going along. The advantage to the steamboat is because it's not powered just by the current, the steamboat can not only go downstream, the steamboat can also go upstream. That's the big thing about the steamboat. The steamboats go both downstream and upstream. So what the steamboat does is the steamboat increases the profitability of the flatboat. The flatboats actually become more profitable